We're going to do some work with ogives. Now an ogive is drawn from cumulative results. Now what that means is, well, in the context of this example, we've got some data taken from the times that athletes took to run 100 metres. So we had 5 athletes took between 10 and 10.5 seconds. 8 athletes took between 10.5 and 11. 14 athletes took between 11 and 11.5 and so on. Now cumulative data is built up like this. What we're looking at is the number of athletes that ran the course in less than, in this case, in less than 10.5 seconds. All of this group did, so the cumulative frequency so far is 5. But if we want to look at the number that ran it in less than 11 seconds, there were these 5 that did it in less than 10.5, plus another 8 that did it between 10.5 and 11, so they all ran it in less than 11 seconds. These 8 and these 5, there are 13 is the cumulative frequency. There were 14 people in the next group. They ran it between 11 and 11.5. Added together with the ones we've counted already, these 13s we've counted already, there will be 27 athletes that ran the course in less than 11.5 seconds. Now what we're doing is we're just graphing that data, and there's a couple of ways to go about it, but one of the easiest is first of all to graph this cumulative frequency data as a histogram. Once you've graphed as a histogram, we put a line inside the histogram starting at 0 and then just connecting together to the top right hand corner of each of the histogram bars. Now that line is called your ogive. Let's have a look at the sort of questions you can do and the way that you can interpret it. At the bottom of the page here, I've redrawn that ogive, this time without the histogram. It just makes it a little easier to see. If I want to find the number of athletes that finished in less than 10.75 seconds, I've got the times here, and up here I should have the cumulative frequency marked. That's the number of athletes. So if I want to know finished in 10.75, there's 10.5, 11 seconds, 10.75 will be exactly in between them. If I go there and go up to my graph, straight up and straight along, gonna have to estimate a little bit. That's 5, 10. It looks like to me about 9 athletes finished in less than 10.75 seconds. How many athletes took longer than 11.2? Let's find 11. 11.5, 11.2, needs a little estimation about there. Let's go up to the graph and go along. Now if we do that, it comes along to about 18. Now that would mean that 18 people finished the course, or the 100 metres, in 18.2 seconds or less than 18.2 seconds. They're the ones that finished in less than that. So if we want the ones that finished in more than 18.2 seconds, we'll have to take it away from the total number of athletes there. There were 40 athletes there. We're saying that 18 finished it in less than 11.2, so that would mean that 22 took more than 11.2. Let's just write it down here. There were 40 minus 18 equals 22. For the sake of your notes, you might like to put a little A there and a little B there, because that's where we're getting our answers from. What fraction of athletes took less than 11.8 seconds? Less than 11.8. So 11.5, 12, 11.8 I reckon would be about there. Up to the graph. Make sure you're keeping your ruler straight. and all we get right up looks to me to be pretty much exactly on, or very close to 35. Looks like 35 out of the 40 athletes finished in less than 11.8 seconds. So the fraction could be 35 out of 40. That answer would be okay like that, and in some ways it makes most sense to say 35 out of 40. That's a fraction. There were 40 athletes there. You could cancel it down if you wished. We're continuing on our way here. We have to now draw ourselves an ogive, and we're doing it from raw data. So first thing that we have to do is tally it on a frequency distribution table. Data's been arranged here. It's in groups. This first group is 40 up to but not including 50, 50 all the way up to 60 but not including 60, and so on. First piece of data is 78, so that'll fit somewhere in this group. Next bit is 45, will fit somewhere in this group. Now I'm going to pause the tape and finish tallying. Maybe you could do that too, and we'll compare our answers. Well, I've done my tallying, and this is what I've come up with. We're going to draw an ogive of the data, but the first thing we need to do is to construct a cumulative frequency column. So there were 2 cars of speed between 40 and 50. So we've counted 2 cars so far. Then there were 5 cars who had speed in the 50s. So all in all, that would make 7 cars, these 5 plus these 2, who had a speed of less than 60. Now there are 13 cars here that were in the 60s, from 60 up to 70. These 13, plus the 7 we've already counted, have all got speeds of under 70. That would make 13 plus 7 is 20. Then there were 6 in this group, 26 cars, 29 cars including these 3, and this last one makes it up to the 30 cars in the survey. Now we're going to put this information on an ogive, and what I'm going to do is probably take the route of drawing in pencil first. I'm going to draw a histogram. Now data doesn't start at 0, it starts at 40. Sometimes it's a good idea to leave a few squares, particularly if there's squares to play with on your graph paper. And I'm going to start my 40s. I'm going to start from here. 2 squares per unit, so that'll be 50, 60, 70, 80, 90, and the last group goes from 90 to 100, doesn't it? Plenty of squares there, and we've just left a little gap here because we didn't start from 0. Up the side I have to get to 30 squares. I think if you go up in 2s you'll fit it nicely. So that'll be 2, 4, 6, 8, 10 cars. $20, $30 is our cumulative frequency maximum. Now to draw that, I'm going to first of all draw a histogram. So I'm just going to do that in pencil. So we had a histogram of this cumulative data up to 2. Then up to 7. By the time we got to 60 we counted 7 cars. That's 7 there. Then up to 20. Up to 26. 29, and finally finishing at 30. Now that would be called a cumulative frequency histogram, and our ogive is going to sit inside that. So we start here, there were no cars of speed less than 40. By the time we got to a speed of 50, we had accounted for 2 cars. By the time we had got to a speed of 60, we had accounted for 7 cars. By the time we had got to a speed of 70, we'd accounted for 20 cars, and so on. Now it's very typical that ogives have kind of got this S shape. That's a very typical shape for an ogive. Now to answer some questions. How many of the vehicles were travelling at a speed of less than 75? You can do that on your graph by going up here to 75, going up to your graph and going along. I might just put these on here. One of my blue pens working. Yes, it is. Go up to 75, go along. You need to be pretty accurate. Now it looks like, well, it's 2022, 23 cars. Had a speed of less than 25. What fraction of the vehicles had a speed of less than 58? So let's find, this we probably should label this as the speeds here. What fraction had a speed of less than 58? 58 here. Up to my graph here. And along. I make it about 6 cars, but we were asked that as a fraction. So it's 6 out of, how many cars were there all in all? 30. 6 out of 30 as a fraction. I could cancel that down, but somehow to me 6 out of 30 seems to make more sense because there were 30 cars in the survey. How many of the vehicles were travelling at a speed of more than 65? Well, remember, the ogive always gives you information about the number travelling a particular speed or less, so we have to be a bit careful here. So if we go up to 65 and go along, now incidentally it doesn't make any difference to your ogive because we're working with a continuous variable. If the question said how many were travelling at a speed of 65 or of a speed less than, it doesn't really make any difference whether you're talking about less than or 65 or less. There's no real difference between those things. Now I get up here 12, probably nearer 13 cars were travelling at a speed of less than 65. But the question didn't ask me that. The question asked me how many were doing more than that. So that means there were 30 cars that were measured. 30 minus 13 equals 17 cars doing more than 65 kilometres per hour. And police are going to fine anyone who's travelling at over 78. How many cars get a fine? So we can go up here to 70, well that was 75, 78 is pretty close. I get 78, will be about there. Up to my graph and go along. I'm going to have to round it off to the nearest car, which is 22, 24. So about 24 we're doing less than 78. That would mean that 30 minus 24 equals 6 cars. Doing more than 78, 6 cars get the fine. Can you see that? Probably not. Let me just fix that just so you can finish it. There we go. Okay, and that's how you draw an O-Dive.